Hello, everyone. In this lesson, we're going to take a look at substitution reactions. As our previous organic reaction lessons have looked at, we're not going to get into the nitty gritty of all the electrons and how they behave and what's causing these bonds to break and new ones to form. We're more focused at this point on just recognizing the type of reaction that might take place, what a potential product might be, and how those atoms are going to combine and recombine. So that's essentially our goal from this. So this reaction is a substitution reaction. And if you think about substitution, it means something is going to take the place of something else. So if you think about a substitute teacher in your class, right, they're replacing the teacher that day. Just like in a substitution reaction, we're going to take an atom off of our organic molecule and we're going to replace it with something else. In this example, we're using Cl2. And for Cl2, so I always like to think about my Cl2, sometimes drawing it as Cl bonded to Cl might help me out. We're going to take our Cl2 and we are going to, in the presence of some ultraviolet light maybe and some heat, we're going to cause a substitution reaction to take place where we're going to end up putting a chlorine atom onto our hydrocarbon. And in the process, a hydrogen is going to come off and end up bonding with our Cl that was remaining from our Cl2. So when we're done, essentially we should produce our organic molecule, which was 4 carbons in this case. And we have now replaced one of those hydrogens with the chlorine. So there's the chlorine in place. It's switched with the hydrogen. And there's our organic molecule. And we'll finish with that byproduct of HCl being produced. Right, so this substitution has taken place. The chlorine has taken the place of the hydrogen in that molecule, and we've produced this particular structure. And this would be called 1-chlorobutane if you were naming this. Okay, so we've got butane, but for 4 carbons, ane because they're all single bonded, and then at the 1 position on my hydrocarbon, I have a chloro. That's the Cl branch. So that's how we name that particular molecule. Now, the interesting thing about this is we could have various isomers produced, right? Where we could, that chlorine could have been ended up bonded to the second carbon and we would get 2-chlorobutane, right? So there are many possibilities. And this is why when we do organic chemical reactions, there's always a process after each step potentially to purify it, right? To remove any unwanted byproducts that get produced and just isolate the individual molecule that we want. Okay, so again, our substitution reaction, one atom is, or sometimes a part of a molecule might take the place of another part of a molecule when we do a substitution. So in this case, we substituted that chloro in place of the hydrogen.